There is a simple question that almost never appears in textbooks or documentaries about human origins. It is not because the question is silly or unscientific. It is because once you ask it seriously, everything that follows becomes unstable. What if we are not the first intelligent species on Earth, not the first humans, not the first tool users, not the first creatures capable of complex thought, planning, technology, or even civilization? What if intelligence did not begin with us, but with something far older that rose, changed the planet, and then vanished long before history began? This question sounds outrageous only because of how we were taught to think about time. Human history feels long to us. 10,000 years seems vast. 100,000 years feels unimaginable. But Earth is not thousands of years old. It is more than 4 billion years old. In that span, all of recorded human civilization occupies less than a thin scratch on the surface of time. When viewed from that perspective, the idea that intelligence might have emerged more than once does not sound impossible. It sounds statistically reasonable. Yet the moment this question is raised, it is often shut down. We are told that there is no evidence. We are told that if such a civilization had existed, we would have found clear traces of it by now. We are told that science has looked and found nothing, but this confidence rests on an assumption that rarely gets examined. The assumption that evidence always survives. The assumption that the geological record is complete. The assumption that intelligence leaves permanent marks that cannot be erased. What if those assumptions are wrong? What if the absence of obvious ruins does not mean nothing existed, but instead means we misunderstand how fragile evidence really is over deep time? This is where the question becomes uncomfortable. Because if it is possible that evidence can be erased, recycled, buried, or misinterpreted, then certainty collapses. And with it collapses the comforting idea that we know where intelligence began. The history we are taught is linear, simple. Life begins. It evolves slowly. Intelligence appears once. Civilization rises once. Everything before us is primitive. Everything after us is progress. It is a story that places modern humans at the peak of a long and inevitable journey. But linear stories are appealing precisely because they remove doubt. They turn complexity into inevitability. They make our existence feel special, protected, and final. Earth does not behave that way. Before we go any deeper, take a moment to let me know in the comments where you are listening from and what time it is for you right now. I genuinely enjoy reading them, and it is always fascinating to see how far these questions travel across the world. And just as a quick note, the visuals you see along the way are meant only to help set the atmosphere and context. As always, thank you for being here and for supporting this journey. Earth resets itself. Continents move. Oceans disappear and return. Entire ecosystems rise and fall. Species that dominated the planet for tens of millions of years vanish so completely that only a handful of fossils remain. Most leave nothing at all. Over 99% of all species that have ever lived are extinct. Most of them left no recognizable trace. Their bones dissolved. Their habitats were crushed, melted, or subducted into the mantle. Their stories ended without witnesses. Why would intelligence be exempt from this process? This is not a question of belief. It is a question of probability. If life arose relatively quickly on Earth, which it did, and if intelligence is an adaptive strategy rather than a miracle, then it becomes difficult to argue that it could only happen once in 4 billion years. Yet we treat the idea as taboo. We rarely ask whether our definition of intelligence is too narrow. We assume it must look like us, think like us, build like us, use the same materials, leave behind cities and monuments that last forever. But even our own cities will not last forever. If humanity disappeared tomorrow, the world would erase us faster than we like to imagine. Within a few hundred years, most buildings would collapse. Within a few thousand, forests would reclaim roads and concrete would fracture into dust. Within 100,000 years, almost everything we built would be unrecognizable. Given 1,000,000 years, even our largest cities would be reduced to thin chemical traces in sediment. After 10 million years, the planet would look untouched. This is not speculation, it is geology. So when we say we would know if someone came before us, what we are really saying is that we believe evidence is permanent. But nothing on Earth is permanent. Not stone, not metal, not even mountains. This is where the question shifts from provocative to serious. If evidence can be erased, then the lack of evidence is no longer proof of absence. It becomes a gap. And gaps are not conclusions. They are invitations to investigate. The problem is that this investigation leads into uncomfortable territory, because once you admit that intelligence could have existed and vanished, you must confront the possibility that some of the anomalies we have already found might not be mistakes or coincidences. You must ask why certain discoveries are explained away quickly, why some data is classified, why some objects disappear into archives and are never discussed again, why questions about deep time intelligence are treated as distractions rather than legitimate lines of inquiry. This is not about accusing science of deception, it is about recognizing how paradigms work. Scientific frameworks determine which questions are considered reasonable. When a question threatens the foundation of a framework, it is often dismissed before it can be tested. The idea that we are not the first intelligent species challenges human exceptionalism. It challenges evolutionary simplicity. It challenges the narrative that intelligence inevitably leads to us and stops with us. And perhaps most dangerously, it challenges the assumption that progress is permanent. Because if others came before us and failed, then intelligence does not guarantee survival. Technology does not guarantee wisdom, and civilization does not guarantee continuity. That realization forces a mirror onto our own moment in history. We live in an age of immense technological power. We manipulate atoms, we alter genomes, we reshape ecosystems, we change the chemistry of the atmosphere itself. If intelligence has appeared before and vanished, then we are not pioneers. We are participants in a pattern, and patterns are only invisible when we refuse to look for them. This series begins with a question, not an answer. The question is not whether we can prove that another intelligent species existed before us. The question is whether we can honestly claim that it did not. Once that certainty is gone, everything changes. Because the Earth is old, time is vast, evidence is fragile, and the stories we tell about ourselves may be far less complete than we were taught to believe. This is the question we were never supposed to ask, and now that it has been asked, we must follow it wherever it leads. In 1972, a discovery was made that should have rewritten everything we think we know about technology, intelligence, and deep time. Instead, it was quietly filed away as a curiosity and then largely forgotten. Deep beneath the uranium mines of Oklo in Gabon, a French scientific team led by physicist Francis Perrin noticed something strange. The uranium ore they were extracting was wrong. Specifically, it contained less uranium-235 than it should have. This mattered because uranium-235 is the isotope used in nuclear reactors and weapons. It is the part of uranium that splits easily and releases enormous amounts of energy. In nature, uranium has a very stable ratio. About 99.3% is uranium-238. About 0.7% is uranium-235. This ratio is consistent across the planet, in rocks, in oceans, in meteorites. It is one of the quiet constants of geology, except at Oklo. At Oklo, the ratio was depleted. Uranium-235 was missing in amounts that could not be explained by ordinary radioactive decay. Something had consumed it. Something had caused nuclear fission to occur. As the investigation continued, the situation became even more difficult to explain. Scientists identified not one, but 16 separate reaction zones spread across the site. These zones showed clear evidence of sustained nuclear fission. Not a brief spike, not a chaotic burst. Controlled reactions that had turned on and off repeatedly over long periods of time. The dating was unambiguous. These reactions had occurred approximately 2 billion years ago. 2 billion years. This was not a few thousand years before recorded history. It was not even a few million years before the first humans. At that time, complex life barely existed. There were no plants, no animals, no oxygen-rich atmosphere. According to everything we are taught, there was nothing on Earth capable of building or operating nuclear technology, and yet the evidence was there in the rock. The official explanation arrived quickly. Too quickly, some would argue. Scientists announced that the Oklo reactors were natural nuclear reactors. A geological accident. An extraordinary coincidence where the uranium concentration, groundwater, and geometry aligned perfectly to sustain fission reactions without human involvement. In this explanation, groundwater flowed through uranium-rich rock, slowing neutrons just enough to allow a chain reaction. As the reaction heated the water boiled away, stopping the reaction. When the rock cooled, water returned and the reaction started again. A natural on-off switch, repeating for hundreds of thousands of years. It sounded elegant. It also required a chain of improbabilities so precise that even the scientists proposing it admitted the conditions were extraordinarily rare. But there were deeper problems. The reaction zones at Oklo were not random. They were spaced in patterns that resembled deliberate placement rather than chaotic geology. The geometry of the zones allowed heat to dissipate evenly. The reactions never went critical. There was no meltdown, no explosion. The system behaved like it had been designed to remain stable. Even more unsettling was the composition of the nuclear waste. The isotopes left behind matched the byproducts of modern nuclear reactors with disturbing accuracy. The same ratios, the same signatures, the same patterns of decay. When scientists from NASA later reviewed the Oklo data, they noted that the reactions appeared moderated, controlled, as if someone had taken steps to manage neutron flow and heat distribution. These are not qualities you expect from a random natural process. Then there was the silence. Much of the Oklo research was classified by the French government. Access to raw data was restricted. Independent researchers found it difficult to obtain samples. Questions about alternative interpretations were discouraged. The story was declared settled. Natural reactors. Case closed. But here is the part that rarely gets mentioned. Even if natural reactors are theoretically possible, Oklo remains unique. In the entire geological record of Earth, only one such site has ever been confirmed. One location where conditions aligned perfectly. One moment in 4 billion years. That alone should raise questions. If this were a natural process, why did it happen only once? Why did it occur in multiple organized zones within the same area? Why do the waste products look so much like engineered systems? And why was the response to the discovery so tightly controlled? There is an alternative explanation that exists mostly in whispers, an explanation that is rarely written down because of what it implies. What if Oklo was not a power plant, but a waste site? What if uranium had been mined, enriched and used elsewhere? And what if the spent fuel was buried in a geologically stable formation designed to contain radiation for immense periods of time? What if the groundwater flow that moderated the reactions was not an accident, but part of a passive cooling system? This would explain the geometry. It would explain the controlled reactions. It would explain why the waste products stayed localized instead of dispersing. It would explain why the reactions never went out of control. It would also require accepting that someone or something had nuclear technology 2 billion years ago. This idea is almost never discussed publicly, not because it has been disproven, but because it is considered unthinkable. It violates the timeline so completely that it cannot be integrated into existing models. And this is where Oklo becomes more than an anomaly. It becomes a test case for how evidence is handled when it threatens foundational assumptions. The rocks do not care about our timelines. Uranium does not care about our theories. Isotopes do not lie. They simply record what happened. At Oklo, something split atoms long before we were supposed to exist. You can choose to believe it was nature performing a miracle once and never again. Or you can choose to sit with the discomfort of uncertainty. Because if Oklo is not natural, then it is not just a mystery. It is a message. A signal from deep time telling us that intelligence, technology, and catastrophe may have occurred long before we arrived. And if that happened once, it opens the door to a far more disturbing possibility. Oklo may not be alone. It may simply be the first crack in a story that was never meant to be questioned. If the Oklo reactors represent a challenge to our understanding of deep time technology, the next category of evidence challenges something even more basic. Not energy or physics, but chronology itself. Throughout the past 2 centuries, objects have been discovered in places where, according to accepted timelines, no intelligent being should have existed at all. These are not myths or legends passed down through folklore. They were physical objects, recovered by ordinary people, documented by newspapers, examined by witnesses, and then quietly removed from public view. The pattern begins in the late 19th century, a time when industrial mining was exposing layers of earth that had been sealed for hundreds of millions of years. In June of 1891, in the small town of Morrisonville, Illinois, a woman named S.W. Culp was breaking coal for her household stove. As one lump split in half, something fell onto the floor. It was a delicate gold chain, about 10 inches long, finely worked, clearly manufactured. The chain was not resting on the surface of the coal. It had been embedded inside it. When the coal broke apart, parts of the chain remained stuck in each half. The coal seam it came from was Carboniferous in age, approximately 300 million years old. The discovery was reported in the local newspaper. Neighbours examined the coal fragments. A jeweller confirmed the chain was genuine gold. Affidavits were signed. There was no suggestion of trickery. Eventually, the artifact was sent to the Smithsonian Institution for examination. No official report was ever released. The chain was never returned. It vanished into storage, where it remains, if it remains at all. 2 decades later, in 1912, workers at a municipal power plant in Thomas, Oklahoma, were breaking coal when they uncovered something even more difficult to dismiss. An iron pot, complete with a spout and handle, fused into the coal itself. The impression of the pot was clearly visible in the surrounding material, indicating the coal had formed around it rather than the object being inserted later. Again, the coal dated to roughly 300 million years old. Again, witnesses documented the find. Photographs were taken. A notarized affidavit was signed by one of the workers, Frank Kennard, who kept a fragment of coal showing the impression. The object was dismissed as a hoax without any serious investigation. How a hoax could result in an iron vessel embedded within solid coal was never explained. The list continues. In 1944, a 10-year-old boy named Newton Anderson discovered a small brass bell embedded in a lump of coal in West Virginia. The bell was ornate, cast rather than crudely shaped, with decorative engravings. His family kept it for years before researchers examined it and noted signs of industrial manufacturing techniques. In 1968, miners in Oklahoma reported finding what appeared to be a paved stone floor 30 feet underground in a coal mine. The stones were fitted together in a deliberate pattern. A geologist was called, samples were taken, photographs were made. Then the section of the mine was sealed, and the report was never published. Each of these discoveries followed the same trajectory: discovery by ordinary workers, documentation by local authorities or newspapers, brief public attention, transfer to an institution, silence. The explanation is always the same: misidentification, contamination, hoax, error. And yet the physical circumstances make these explanations increasingly difficult to accept. Coal does not form around modern objects. The pressures and temperatures involved in coalification would destroy metal, distort shapes, or leave obvious signs of intrusion. Coal seams are dated using multiple independent methods, including stratigraphy and fossil markers. Their ages are not guesses. To accept that all of these cases are hoaxes requires believing in a coordinated pattern of deception across different states, different decades, and different social contexts, all producing the same type of anomaly. Manufactured objects embedded in ancient coal. That explanation begins to strain credibility. A simpler possibility exists, though it is far more unsettling. What if these objects were not placed there by modern humans at all? What if they belonged to a world so old that its remains were buried, compressed, and transformed into the fuel that powers modern civilization? The irony is difficult to ignore. We burn coal to run our machines, unaware that coal itself is the compressed remains of ancient ecosystems, forests that lived and died hundreds of millions of years ago, entire worlds turned into black stone. If something intelligent existed in those worlds, its artifacts would not survive as ruins or cities. They would survive, if at all, as anomalies. Isolated objects trapped in geological processes far larger than themselves. This possibility introduces a troubling thought. Perhaps we are not failing to find evidence of ancient intelligence. Perhaps we are finding it, but we do not recognize it because it does not fit the story we expect to see. We look for pyramids. We look for cities. We look for inscriptions and monuments. But what if the only things that survive are fragments? A chain, a pot, a bell, a floor buried so deep it is never meant to be seen again. When such objects appear, they do not inspire investigation. They inspire discomfort. And discomfort is often resolved not by asking better questions, but by making the problem disappear. These are not just out-of-place artifacts, they are out-of-place questions. Questions about time, about continuity, about whether intelligence leaves the kind of footprint we assume it does. If even one of these objects is genuine, then the implications are profound. It would mean that intelligence existed on Earth long before humans, worked metal, created tools, and vanished so completely that only scattered traces remain. And if that is possible, then the boundaries of history stretch far beyond what we have been taught. These objects do not prove that another intelligent species existed before us, but they do something more dangerous. They show that certainty is fragile, and they force us to confront the possibility that the past is not empty, but forgotten. If the objects found in coal challenge our understanding of time, the next discovery challenges something even more fundamental: the very idea of when intelligence could exist at all. In the mountains of South Africa, miners have been finding strange objects for more than a century. They are small, roughly spherical, and unnervingly precise. At first glance they look simple, but the deeper you examine them, the less sense they make. These objects are known as the Klerksdorp spheres. They are found embedded in a type of rock called pyrophyllite, a hard metamorphic stone formed approximately 2.8 billion years ago. Not million, billion. At that point in Earth's history, the planet was almost unrecognizable. There were no plants, no animals, no trees, no oxygen-rich atmosphere, Life consisted almost entirely of single-celled organisms drifting in ancient seas. According to every accepted model of biology and evolution, nothing capable of deliberate design should have existed. And yet the spheres exist. They range from about 1 to 4 inches in diameter. Some are solid, others are hollow and filled with a spongy material. Some are composed of iron-nickel alloy. Others appear to be made of pyrite. But the most disturbing feature is shared across many of them. 3 perfectly parallel grooves running around the equator of each sphere. The grooves are evenly spaced, uniform in depth, consistent in alignment. They are not random scratches. They do not vary chaotically as you would expect from erosion or crystal growth. They look machined. Geologists have proposed explanations. They call the spheres natural mineral concretions. Formations created as minerals precipitate around a nucleus over time. This explanation works reasonably well for the spherical shape itself. Nature can produce round objects, but it fails when confronted with the grooves. No known geological process produces evenly spaced parallel bands around a spherical object with this level of precision. No process explains why the grooves appear only on spheres from this specific geological layer and nowhere else in Earth's history. Museum curators often display the spheres with vague labels. Natural formation, geological curiosity, origin unknown. When pressed for details, many admit privately that they do not know how the spheres formed. One curator, Roalf Marx, who studied the spheres for decades at a South African museum, publicly stated that no known natural process can explain their features. He described them as a complete mystery, but he stopped short of offering any alternative explanation. There is a reason for that. Any alternative explanation immediately collides with the timeline of life on Earth. The discomfort deepens when you examine what happened to one of the spheres after it was placed on display. In the early 2000s, a Klerksdorp sphere was placed inside a sealed glass case on a flat surface. The case was isolated from vibrations. There were no moving parts, no environmental disturbances. Over the course of several months, museum staff noticed something strange. The sphere had rotated, not rolled off its base, not fallen. It had slowly turned on its axis. Marks placed on the sphere confirmed that the rotation was real and measurable. There was no explanation, no magnetic anomaly, no uneven weight distribution sufficient to account for the movement. Eventually, the sphere was removed from public display. Stories like this are easy to dismiss as exaggeration, but the physical objects remain. Hundreds of spheres recovered from the same geological context, all displaying the same inexplicable features. The usual defense is to isolate each detail and downplay it. Grooves are coincidental. Rotation is anecdotal. Precision is overstated. Mystery does not equal intelligence. And that is true. Mystery alone proves nothing. But patterns matter. Why do these objects appear only in rocks from 2.8 billion years ago? Why do they show consistency across hundreds of specimens? Why do their features resemble deliberate design more than random formation? And why has no experimental geology been able to reproduce anything similar? If these spheres were found in younger rock layers, they would spark intense investigation. If they were found in association with early human cultures, they would be hailed as revolutionary artifacts. But because they exist in a time where intelligence is not allowed to exist, they are quietly minimized. This is how anomalies are neutralized, not by disproving them, but by stripping them of significance. The Klerksdorp spheres force an uncomfortable realization. Our timelines are not neutral frameworks. They act as filters. They determine what is possible before the evidence is even examined. Anything found outside the accepted window of intelligence is automatically interpreted as natural, no matter how artificial it appears. The conclusion comes first. The explanation follows. But what if that filter is blinding us? What if intelligence does not always look like cities and machines? What if it appears briefly, leaves subtle traces, and is erased by time? What if the only thing that survives is something small, something durable, something we mistake for a curiosity? The spheres do not tell us who made them, or how, or why. They may not even be artifacts in the way we understand the term, but they do tell us something important. They tell us that our certainty about the deep past is far greater than our actual knowledge, and they remind us that the most dangerous discoveries are not the ones that shout their meaning, but the ones that sit quietly in museum cases, forcing us to ask questions we do not want to answer. If intelligence once existed on Earth in forms we do not recognize, the Klerksdorp spheres may be among the oldest whispers of that forgotten world. And whispers are easy to ignore until you realize how old they are. For a long time, the idea that intelligence might have existed on Earth before humans was treated as a distraction. It belonged to speculation, not science. Serious researchers did not ask such questions because the answers were assumed to be obvious. Then something unusual happened. In 2018, two scientists published a paper that did not claim ancient civilizations existed, but asked a far more dangerous question. Would we even be able to tell if they had? The paper became known as the Silurian hypothesis. It was written by Gavin Schmidt, the director of NASA's Goddard Institute for Space Studies, and Adam Frank, a professor of astrophysics at the University of Rochester. These were not fringe thinkers. They were mainstream scientists working at the highest levels of their fields. Their question was simple and unsettling. If an industrial civilization had existed on Earth millions of years ago, would the geological record preserve clear evidence of it? Most people assume the answer is yes. We imagine ruins, cities, machines, monuments, something obvious, something undeniable. Schmidt and Frank challenged that assumption. They began by examining the nature of the geological record itself. Rocks do not record everything. They record fragments. Sediments are eroded, plates are subducted, oceans are recycled, heat and pressure erase detail. What survives is not a complete archive, but a distorted and incomplete one. Geologists estimate that we have access to far less than 1% of all sedimentary rock that has ever existed on Earth. The rest has been destroyed or transformed beyond recognition. That means 99% of Earth's history is missing. Against that backdrop, Schmidt and Frank asked what kinds of traces an industrial civilization might actually leave behind over deep time. Not buildings, not roads, not artifacts. Those would vanish quickly. Instead, they focused on chemical and isotopic signatures. Our own civilization is altering the planet in measurable ways. We burn fossil fuels, releasing ancient carbon into the atmosphere. We change nitrogen cycles through fertilizer production. We spread synthetic compounds across land and sea. We create radioactive isotopes through nuclear activity. These changes leave signals. But even these signals are not permanent. Plutonium does not last long on geological timescales. After a few 100,000 years, it decays into lead. Most synthetic chemicals break down. Plastics fragment. Even dramatic climate shifts eventually blend into background noise. Schmidt and Frank concluded that after tens of millions of years, almost all direct evidence of an industrial civilization would be ambiguous at best. Future scientists might notice strange chemical spikes. They might see anomalies, but they would not be able to say with certainty what caused them. In other words, absence of clear evidence would not mean absence of civilization. It would mean the evidence had faded. This conclusion did not prove that ancient civilizations existed, but it destroyed the confidence that they could not have existed. That distinction matters. Science is often portrayed as a collection of facts. In reality, it is a framework of assumptions built on available evidence. When evidence is incomplete, assumptions fill the gaps. The Silurian hypothesis exposed just how large those gaps really are. It also revealed something else. The reason the question of ancient intelligence feels forbidden is not because it violates evidence. It is because it violates expectation. We expect intelligence to be rare. We expect it to look like us. We expect it to progress steadily toward modernity. We expect ourselves to be the end point. The Silurian hypothesis removes that comfort. It suggests that intelligence could be a transient phenomenon, a brief flare in deep time, appearing, altering the planet, then disappearing so thoroughly that even its own footprints are misread. After the paper was published, reactions were cautious. Some praised the thought experiment, others dismissed it as academic curiosity. Few followed its implications to their logical end. But the door had been opened. If science admits that it cannot rule out ancient industrial civilizations, then certainty collapses. The timeline is no longer closed. The past becomes conditional rather than fixed. This is not a failure of science. It is a moment of honesty. It acknowledges that our confidence about being first rests not on proof, but on assumption. It acknowledges that deep time is hostile to memory. And it acknowledges that some of the anomalies already discovered may deserve a second look. The Silurian hypothesis does not claim we are not the first intelligent species. It claims something more unsettling, that we do not know. And once that uncertainty is admitted, every unexplained isotope ratio, every strange object, every erased anomaly stops being an inconvenience and starts becoming a clue. Science did not close this question. It quietly opened it, and in doing so, it forced us to confront the possibility that the history of intelligence on Earth is far older, far stranger, and far less certain than we were ever taught to believe. The most common objection to the idea of an ancient intelligent species is simple and confident. If something like that had existed, we would have found clear evidence by now. This belief feels intuitive. Cities feel permanent. Stone feels eternal. Technology feels durable. We imagine that once something is built, it leaves a mark forever. Geology tells a very different story. On Earth, nothing is built to last. Not continents, not oceans, not mountains. Everything is temporary when measured against deep time. Consider our own civilization. Right now, we cover the planet with concrete, steel, glass, and plastic. Our cities are visible from space. Our infrastructure spans continents. It feels impossible that this could ever disappear, but remove humans from the equation, and the clock starts ticking immediately. Within decades, buildings begin to decay. Metal rusts, roofs collapse, roads crack, vegetation returns. In a few centuries, most cities would be unrecognizable ruins. In a few thousand years, forests would erase almost every trace of urban life. In 10,000 years, concrete would fracture into dust and soil. After 100,000 years, even the largest cities would leave only faint chemical signatures. After 1 million years, almost nothing recognizable would remain. After 10 million years, the planet would look as though we were never here at all. This is not speculation. These are well-understood processes. Erosion, weathering, biological activity, and tectonic movement are relentless. Now expand that timescale. The ocean floor is recycled roughly every 200 million years. Entire continents are dragged into the mantle and melted. Sedimentary layers are folded, crushed, and transformed by heat and pressure. What survives is not what existed, but what happened to be preserved under ideal conditions. Most of Earth's surface has been reset multiple times. This is why the fossil record is so sparse. Only a tiny fraction of organisms ever fossilize. Only a fraction of those fossils survive erosion. Only a fraction of those are ever discovered. We reconstruct entire worlds from fragments because that is all that remains. Civilizations would fare worse. Cities are not buried gently. They are eroded, scattered, and chemically altered. Tools corrode, structures collapse, artifacts dissolve. Over millions of years, the difference between a city and a natural formation disappears. Even stone does not endure the way we imagine. Limestone dissolves in acidic water. Granite fractures under thermal stress. Basalt erodes. Given enough time, mountains become sediment. This means that if an intelligent species existed tens or hundreds of millions of years ago, the likelihood of finding its cities today is extremely low. But what about durable materials? What about metal? Metals oxidize, iron rusts and returns to ore. Aluminum reacts and disperses. Copper corrodes. Gold survives longer, but only as isolated fragments. Metal objects do not last forever. They cycle back into the earth. What about technology? Machines, infrastructure. The more complex a system is, the more fragile it becomes over time. Power grids fail. Reactors decay. Knowledge vanishes when populations collapse. Without continuous maintenance, technology destroys itself. Civilizations are not just physical systems. They are informational systems. When communication breaks, skills are lost. Techniques disappear. Written records decay. Memory fades. History itself is fragile. We know this from our own past. Entire cultures have vanished within a few centuries. Languages have gone extinct. Knowledge has been lost and rediscovered multiple times even within recorded history. Now imagine this process stretched across millions of years. The silence of deep time is not evidence that nothing happened. It is the expected outcome of everything that happened being erased. This realization reframes the question completely. We are not asking why we have not found ancient civilizations. We are asking why we expect to. The Earth is not an archive. It is a grinder. It destroys information as efficiently as it creates it. Only under rare circumstances does something survive. An object trapped in sediment, a chemical anomaly locked in stone, an isotope ratio preserved by chance. These are not monuments, they are whispers, and whispers are easy to dismiss. Once you understand how aggressively the planet erases its own past, the question changes. It is no longer why there is so little evidence of ancient intelligence. It is why there is any at all. If intelligence emerged before us, its traces would not be obvious. They would be scattered, incomplete, and easily misinterpreted. They would look like anomalies rather than proof, which means that the few anomalies we have found may not be coincidences. They may be exactly what we should expect. And if that is true, then the problem is not the absence of evidence. The problem is that we have been looking for the wrong kind. If cities crumble and machines vanish, something else may remain. Not structures you can touch, but changes written into the chemistry of the planet itself. Civilizations do not just build things. They alter environments. They change the balance of elements. They leave chemical fingerprints that persist long after physical objects are gone. Our own civilization is doing this right now. By burning fossil fuels, we are releasing carbon that was locked underground for hundreds of millions of years. That carbon carries a distinct isotopic signature. Living organisms prefer one form of carbon over another, and fossil fuels preserve that preference. When we burn them, the ratio of carbon isotopes in the atmosphere, oceans, and sediments shifts. Geologists already use this signal to define a new geological interval, often called the Anthropocene. It is a thin chemical layer, not a city or a monument. A future geologist would not see skyscrapers. They would see an unusual spike in carbon isotopes and ask what caused it. The unsettling part is this. When scientists examine ancient rock layers, they find similar spikes. There are moments in deep time when carbon isotope ratios shift suddenly and dramatically. The Paleocene-Eocene thermal. Maximum 56 million years ago is one example. Global temperatures rose rapidly, oceans acidified, life struggled. The standard explanation involves massive releases of methane or volcanic activity, but the chemical pattern looks strikingly similar to rapid combustion of organic material on a global scale. Another example appears at the Permian-Triassic boundary, the same interval associated with the greatest mass extinction in Earth history. The carbon shift there is one of the most extreme ever recorded. It is usually attributed to volcanic eruptions, yet the initial chemical change appears before the main phase of volcanism. These events are treated as natural catastrophes, but chemically they resemble planetary-scale disruptions of the carbon cycle. The same kind of disruption an industrial civilization would cause if it burned enormous amounts of stored carbon. Carbon is not the only element that tells this story. Nitrogen cycles are also sensitive to technological interference. Modern agriculture produces synthetic fertilizers by pulling nitrogen from the atmosphere and converting it into reactive forms. This process alters nitrogen isotope ratios across soils, rivers, and oceans. Ancient sediments show sudden nitrogen anomalies at several points in Earth's history. Spikes that appear too rapidly and at too large a scale to be explained easily by natural biological processes alone. These anomalies are usually attributed to changes in ocean circulation or microbial activity, but the timing and magnitude often raise questions that remain unanswered. Then there are synthetic compounds. We like to think of plastics as uniquely modern, but when researchers analyzed deep ocean sediment cores, they identified long-chain hydrocarbon polymers in layers hundreds of millions of years old. The official explanation was contamination during drilling, yet the compounds appeared at depths and concentrations that made surface contamination difficult to explain. No follow-up studies were funded. Radioactive isotopes add another layer of complexity. Plutonium does not last long geologically, but uranium and thorium do. Their ratios change in predictable ways when nuclear reactions occur. These ratios are remarkably consistent across the solar system, except where they are not. The uranium anomalies at Oklo are the most dramatic example, but they may not be the only ones. Subtle variations in isotope ratios have been detected in ancient formations and are often dismissed as measurement error or natural irregularity. Individually, they mean little. Together, they form a pattern that is difficult to ignore. Chemistry has no memory of intention. It records only what happened. It does not know whether a reaction was caused by a volcano, a meteor, or a machine. It only preserves the outcome. That is why chemical evidence is both powerful and dangerous. It cannot tell us who acted, only that something acted. When we encounter unexplained chemical signatures, we face a choice. We can force them into existing models, or we can admit that our models may be incomplete. The prevailing approach has been to explain each anomaly in isolation. One spike is volcanic, another is biological, another is contamination. Each explanation is plausible on its own, but taken together, they describe repeated, rapid, global disruptions of planetary chemistry. The same disruptions we are causing today. This does not prove that ancient civilizations existed, but it undermines the certainty that they did not. It shows that the planet has experienced chemical events that resemble industrial activity more than slow natural change. These are not ruins. They are not artifacts. They are chemical ghosts, faint, ambiguous, easy to dismiss. But once you know what to look for, they stop looking like noise and start looking like echoes. And if echoes exist, then something must have made the sound. When we imagine intelligence in the deep past, we almost always imagine it wearing a human face. Hands, eyes, upright posture, tools that look familiar. This assumption quietly shapes every conclusion we draw. But Earth does not care about our preferences. For most of its history, the planet was ruled by worlds that had nothing to do with humans. Entire biological eras rose and fell long before our lineage appeared. Each of these eras lasted tens of millions of years, time enough not just for evolution, but for experimentation. The first of these worlds challenges a simple belief: that intelligence requires a human brain. During the Permian period, roughly 250 million years ago, the dominant land animals were not dinosaurs. They were therapsids, often called mammal-like reptiles. These creatures are usually portrayed as transitional and primitive. That portrayal is misleading. Fossil skulls show that some therapsids had brain-to-body ratios far higher than most reptiles. Their teeth were specialized, not uniform spikes, but differentiated tools for cutting, tearing, and grinding. This implies complex feeding behavior and advanced processing of food. Some species show evidence of social behavior: group living, parental care, possibly communication. These are not the traits of simple animals reacting purely on instinct. They suggest planning, memory, and coordination. Could such creatures develop tool use? Could they manipulate their environment in ways that do not fossilize easily? Mainstream science says no, but it once said the same about birds, octopuses, and insects. Intelligence is not a single thing, it is a strategy. Now move further back. During the Carboniferous period, Earth existed under conditions we no longer experience. Oxygen levels were dramatically higher than today. As a result, life grew larger, much larger. Insects the size of birds dominated the skies. Arthropods grew to lengths measured in feet rather than inches. These were not clumsy giants. They were agile predators with complex sensory systems. Modern insects already demonstrate navigation, memory, problem-solving, and communication. They build structures. They coordinate actions. They adapt rapidly. What happens when such organisms are given millions of years under conditions that favor size, energy, and complexity? We have no evidence that Carboniferous life developed technology, but we also have almost no evidence of anything that life did during those 60 million years beyond what happened to fossilize by chance. The fossil record from this period is notoriously incomplete. Vast ecosystems are represented by a handful of impressions in stone. Entire behaviors vanish without a trace. Now go further back still, before animals with skeletons, before familiar body plans, before anything that resembles modern life. The Ediacaran period presents a world that feels alien. Soft-bodied organisms covered the seafloor. Some were several feet across. Their shapes were fractal, quilted, unlike anything alive today. Scientists still debate what these organisms were. Some argue they were early animals. Others suggest they were something else entirely. A failed experiment in complex life. There are fringe hypotheses that these organisms used biochemistry unlike ours, that they did not rely on DNA in the way modern life does, that they processed energy and information in ways we do not understand. This idea is uncomfortable. It implies that intelligence might not even require the biological framework we consider fundamental. Could such organisms think, not like us, not individually, but as networks, distributed systems processing information across vast surfaces? There is no evidence for this, but there is also almost no evidence against it. The Ediacaran world lasted tens of millions of years, then it vanished almost entirely. When the Cambrian explosion began, those organisms were gone, replaced by creatures with shells, skeletons, and body plans that dominate life today. Whatever intelligence might have existed in that world, if any, would be erased. Soft bodies do not fossilize well. Behaviors leave no trace. Only faint impressions remain. What these ancient worlds demonstrate is not that intelligence existed before humans. They demonstrate that the opportunity existed. Time, energy, complexity, ecological pressure. These are the ingredients evolution works with. Earth has provided them repeatedly. We are taught to see evolution as a ladder, each rung leading inevitably to us. That story is comforting. It makes intelligence feel destined. In reality, evolution is a maze. Paths branch. Dead ends dominate. Most experiments fail. A few succeed briefly. Almost all are forgotten. If intelligence is rare, it may still occur more than once in 4 billion years. If it is fragile, it may vanish without leaving obvious evidence. And if it does not look like us, we may not recognize it, even if traces remain. The question is not whether ancient worlds could have supported intelligence. The question is why we assume they did not. Because once we admit that intelligence is not bound to a single form or a single moment, the history of Earth becomes far more open and far more unsettling. We stop being the beginning, we become a chapter. If intelligence arose in earlier worlds, there is an unavoidable question that follows. What happened to it? The history of life on Earth is not smooth or gradual. It is punctuated by sudden collapses. Moments when the planet seems to reset itself, wiping out complexity and starting again from simpler forms. These are known as mass extinctions. Scientists usually describe them as natural disasters, asteroids, volcanoes, climate shifts, random catastrophes that reshaped life through no fault of the organisms involved. And in many cases, these explanations are broadly correct. But when you examine the details closely, some extinctions behave in ways that are difficult to reconcile with slow natural processes alone. The most extreme example occurred around 252 million years ago. It is called the Permian extinction, often referred to as the Great Dying. It eliminated more than 90% of marine species and around 70% of land vertebrates. Entire ecosystems vanished. Forests collapsed. Oceans became toxic. Nothing like it has happened before or since. The standard explanation points to massive volcanic eruptions in what is now Siberia. These eruptions produced vast lava flows and released enormous quantities of carbon dioxide and sulfur gases. The climate destabilized. Oceans acidified. Oxygen levels dropped. The evidence for volcanism is real. The lava flows exist. The timing broadly matches. But the details raise uncomfortable questions. First, the speed. Geologically speaking, the extinction happened almost instantly. Some estimates suggest the majority of species disappeared within less than 60,000 years. In deep time, that is an eye blink. Volcanism typically operates over much longer timescales. Even massive eruptions unfold in phases. They poison environments gradually. They stress ecosystems over extended periods. The Permian collapse looks more like a cascade than a slow decline. Second, the pattern. The extinction involved rapid swings between cooling and extreme warming. Acid rain on a scale that dissolved limestone. Ocean anoxia so severe that vast regions became lifeless. These changes appear to have happened in chaotic pulses rather than a single, steady trend. Third, the chemistry. Carbon isotope records show a dramatic shift at the Permian boundary, but the initial spike appears slightly before the main volcanic phase, as if something triggered the volcanism rather than the other way around. These inconsistencies do not prove an alternative cause, but they suggest that the story may be incomplete. A few researchers have quietly raised a provocative possibility. What if the Permian extinction was not purely natural? What if it was accelerated or triggered by a chain of events that included technological activity? This idea is not supported by direct evidence. There are no machines buried in Permian rock, no cities, no tools. But consider what a technological civilization might do under extreme stress. If a civilization altered climate on a planetary scale, destabilized geological systems, or triggered feedback loops it could not control, the resulting collapse would look natural in the rock record. Volcanoes would still erupt, oceans would still acidify, life would still die. But the initial cause would be gone. The planet would erase the fingerprints and preserve only the aftermath. This is not a claim, it is a question. And it applies not only to the Permian extinction. Other mass extinctions show similar oddities. The Ordovician extinction around 445 million years ago involved sudden glaciation during a warm period. Carbon dioxide levels dropped rapidly. Ice sheets formed with little warning. The cause remains debated. The Devonian extinction unfolded in multiple pulses, marked by widespread ocean anoxia and chemical anomalies that do not align neatly with known triggers. Even the extinction that killed the dinosaurs, often cited as the clearest example of an asteroid-driven catastrophe, shows complexity. Volcanism, climate stress, and impact effects overlapped in ways that are still being studied. Each extinction is explained individually. Each has a plausible natural mechanism, but collectively they reveal a pattern. Rapid collapse, reset, long recovery, new dominance. If intelligence existed before humans, mass extinctions would be the perfect eraser. They would not just kill populations, they would destroy infrastructure, disrupt knowledge transmission, and bury or recycle physical evidence. The survivors would be small, simple, adaptable, burrowers, aquatic organisms, life forms that leave minimal trace. Complex systems do not survive planetary chaos. After the Permian extinction, it took more than 10 million years for ecosystems to recover. 10 million years of biological silence. When life returned, it was different. The dominant groups were gone. New ones rose. The world was rewritten. This is what makes mass extinctions so important to the question of ancient intelligence. They are not just biological events. They are historical erasers. If civilizations existed before us, they would not be neatly layered beneath our feet. They would be shattered, scattered, and chemically transformed beyond recognition. All that would remain are patterns, abrupt changes, anomalies that look natural because nature finished the job. The unsettling thought is not that intelligence might have existed before us. The unsettling thought is that Earth may have erased it so completely that we mistake the silence for proof that it never existed at all. And if that has happened before, it forces a difficult question about the present. Are we living in a stable chapter of history, or are we approaching another reset? If mass extinctions erase deep time civilizations beyond recognition, the Younger Dryas stands apart for a different reason. It is not distant, it is close enough to remember, or at least close enough that memory should exist. Around 12,800 years ago, Earth experienced a sudden and violent climate reversal. The planet had been warming steadily as the last ice age ended. Ice sheets were retreating. Ecosystems were stabilizing. Human populations were expanding. Then, almost overnight in geological terms, the temperature dropped. Within a few decades, large portions of the northern hemisphere were plunged back into near-glacial conditions. Ice advanced. Drought spread. Megafauna began to disappear. Human cultures collapsed or scattered. This event is known as the Younger Dryas. For decades it was explained as a disruption of ocean currents. Meltwater from retreating glaciers was thought to have flooded the North Atlantic, shutting down heat transport and cooling the planet. This explanation was neat. It was also incomplete. As more data emerged, cracks appeared. Sediment layers dating to the onset of the Younger Dryas contain unusual materials. Tiny diamonds formed under extreme pressure. Spherules, consistent with high-temperature melting, elevated platinum levels across multiple continents, burn layers suggesting widespread fires. These are not signatures of gradual climate change. They resemble impact events. A growing number of researchers have proposed that fragments of a comet or asteroid struck or exploded over Earth during this period. Not a single impact crater, but a swarm. Airbursts, shockwaves, fires, atmospheric disruption. The debate is ongoing and controversial, but regardless of the cause, the effects are undeniable. Human societies across the world were disrupted at the same time. Settlement patterns changed abruptly. Technologies vanished. Population numbers declined. This alone would be remarkable. But the Younger Dryas holds another anomaly that complicates the story even further. At the end of this chaotic period, just as the climate stabilized again, something unexpected appeared. Monumental architecture. At a site called Göbekli Tepe in modern Turkey, massive stone pillars were erected in circular enclosures. The stones weigh up to 50 tons. They were carved with precise reliefs of animals and symbols. They were arranged with astronomical awareness. This site dates to around 11,600 years ago. According to conventional history, humans at this time were hunter-gatherers, small groups, temporary shelters, no agriculture, no cities, no organized labor capable of building monumental structures. And yet Göbekli Tepe exists. There are no nearby quarries with simple explanations, no gradual evolution of architecture leading up to it. It appears suddenly, fully formed, then is deliberately buried. Not abandoned, buried. This suggests memory, planning, intent. It suggests that the people who built Göbekli Tepe knew something had ended, and they chose to preserve knowledge rather than expand it. Similar questions arise elsewhere. Ancient maps appear showing coastlines as they would have existed at the end of the last ice age. The Piri Reis map depicts parts of Antarctica without ice, something that should have been impossible for medieval cartographers. These maps are often dismissed as errors or imaginative reconstructions, yet their accuracy in specific regions is difficult to explain. Myths from cultures across the world tell remarkably similar stories. A great flood, fire from the sky, a golden age destroyed, survivors who carry knowledge into a diminished world. These myths are often treated as symbolic or metaphorical, but symbols often preserve memory when direct history is lost. The Younger Dryas sits at a strange intersection. It is recent enough that human witnesses almost certainly existed. It is violent enough to erase complex societies. And it is followed immediately by the sudden appearance of advanced construction. This raises a troubling possibility. What if the people who built Göbekli Tepe were not inventing civilization? What if they were rebuilding after its collapse? What if the Younger Dryas was not just a climate event, but a civilizational reset? This does not require lost continents or global empires. It requires only that advanced societies existed regionally, coastal, vulnerable, and that they were destroyed quickly. Sea levels rose dramatically at the end of the Ice Age. Vast coastal plains were flooded. Settlements would have been swallowed. Evidence submerged. The survivors would move inland. They would carry fragments of knowledge. They would remember that something greater existed before. And over generations, that memory would become myth. The Younger Dryas may represent the closest we can come to seeing this process in action. Not in deep time, but at the edge of history, a moment when civilization may have risen earlier than we were taught, fallen violently, and left behind only hints. Hints carved in stone, hints buried intentionally, hints scattered across maps and stories. It is not proof, but it is uncomfortably consistent. And if this happened once within human memory, it makes the idea of earlier forgotten intelligences far less abstract. It makes it personal. because this time the ruins are not buried beneath hundreds of millions of years. They are just beneath the surface, waiting. If the Younger Dryas suggests a civilization we almost remember, there are places on Earth that feel like memories we are not allowed to fully examine. These are not obscure locations. They are famous sites studied by archaeologists, photographed by tourists, and discussed in textbooks. Yet beneath their familiarity lies something unresolved, something that does not fit. Consider Baalbek. In modern Lebanon, the ruins of Baalbek sit atop a platform so massive it defies casual explanation. The stones known as the trilithon weigh up to 800 tons each. They were quarried, transported, lifted, and placed with precision that rivals modern engineering. No cranes, no steel cables, no engines. Mainstream explanations suggest Roman construction techniques. But this raises an obvious problem. The Romans did not build foundations for temples at this scale. There is no evidence of machinery capable of moving stones of this size, and the platform beneath the Roman structures appears far older than the Roman occupation itself. Baalbek looks less like a Roman project and more like something inherited. Then there is Pumapunku in Bolivia, blocks of stone shaped with such precision that they interlock like machine-cut components. Angles repeat perfectly. Holes are drilled at consistent depths and diameters. Surfaces are flat to tolerances that challenge even modern stoneworking. Yet the official timeline places Pumapunku thousands of years before the invention of metal tools capable of such work. Explanations invoke lost techniques using stone hammers and copper chisels. But no experimental archaeology has successfully reproduced the results at scale. The stones remain silent witnesses to a level of skill that appears out of place. Across the ocean in Japan lies Yonaguni, a submerged structure discovered off the coast that resembles a stepped pyramid carved directly into bedrock. Sharp angles, terraces, stair-like features, straight edges extending for hundreds of feet. Some geologists argue it is natural. Others see unmistakable signs of human modification. The debate has never been settled. What makes Yonaguni especially uncomfortable is its location. Submerged at a depth consistent with sea level rise after the last ice age, a place that would have been dry land during the Younger Dryas. If it is artificial, it means construction occurred before accepted history allows. And then there is Antarctica, an entire continent locked behind international treaties, a landmass where independent exploration is restricted and research is tightly regulated. Officially, this is to protect the environment and promote peaceful science. Unofficially, it has become a place where anomalies accumulate without resolution. Satellite imagery reveals geometric shapes beneath the ice. Subglacial lakes remain unexplored. Radar scans hint at structures buried deep below frozen layers that have existed for millions of years. Every anomaly is explained individually. Ice formations, radar artifacts. Coincidence? But the pattern is familiar. When places challenge the timeline, access becomes limited. When data raises uncomfortable questions, it is archived rather than investigated. When hypotheses threaten established narratives, funding disappears. This is not a conspiracy in the cinematic sense. It does not require secret meetings or hidden masters. It requires only institutional inertia. Science progresses by building on accepted frameworks. Careers depend on staying within them. Grant committees fund safe questions. Journals publish work that fits existing models. Radical questions are risky. As a result, certain subjects become effectively forbidden, not officially banned, but quietly avoided. Young researchers learn what not to pursue. Senior academics learn what not to challenge. Over time, entire categories of inquiry fade. This is how missing data is created, not by destroying evidence, but by never collecting it. Artifacts are stored and forgotten. Sites are labelled and left alone. Anomalies are explained just enough to remove urgency. The unknown is wrapped in language that sounds definitive. Natural formation, ritual site, symbolic structure, measurement error. These phrases end conversations. The uncomfortable truth is that archaeology and geology are not neutral observers of the past. They are interpretive sciences. They tell stories based on incomplete evidence. And stories have boundaries. When stones appear too large, they are attributed to lost methods. When cuts are too precise, they are explained away. When dates do not fit, they are adjusted or dismissed. This does not mean deception. It means protection of coherence. But coherence can become a cage. If intelligence existed before us, its most durable works would not be cities of wood and steel. They would be stone, massive, integrated into the landscape, so old that later cultures built on top of them without understanding their origin. And those are exactly the kinds of structures that raise the most resistance when questioned. The forbidden places are not forbidden because they are dangerous. They are forbidden because they are destabilizing. They remind us that history is layered, that knowledge can be inherited without comprehension, and that we may be walking on foundations laid by minds we no longer recognize. The question is no longer whether these sites can be explained. The question is whether we are willing to let the explanation change the story we tell about ourselves. Because once the stones speak, the timeline begins to crack. And cracks have a way of spreading. After everything we have seen, the final question does not belong to geology or archaeology. It belongs to power. If traces of earlier intelligence exist, fragmented and ambiguous, then the most unsettling possibility is not that they were erased by time alone. It is that some of them may have been ignored, sidelined, or quietly removed once discovered. This is not a claim of a single secret hand guiding history. It does not require a shadowy organization controlling all knowledge. The reality is both simpler and more disturbing. Knowledge is filtered. Institutions decide what is preserved, what is studied, and what is taught. Museums choose what goes on display. Universities decide which research is funded. Journals determine which papers are published. Over time, these choices shape reality itself. When evidence fits the accepted story, it is amplified. When it does not, it is minimized. Throughout modern history, artifacts that challenge timelines have often followed the same path. They are collected, catalogued, stored, then forgotten, not destroyed, just removed from discussion. The Smithsonian Institution is frequently mentioned in this context, not because it is unique, but because it is emblematic. It houses millions of artifacts. Only a tiny fraction are ever displayed. The rest sit in storage, inaccessible to the public, sometimes even to researchers. This is not sinister. It is practical. But it also means that what we see is not the whole record. It is a curated one. The same applies to archaeological sites. Excavation is selective. Only certain layers are explored. Only certain interpretations are emphasized. Once a site is labeled and dated, further questions often stop. Reopening a settled conclusion is risky. It can unravel careers. It can invalidate decades of work. It can force institutions to admit uncertainty where certainty was promised. And uncertainty is uncomfortable. There is also a deeper reason why the idea of prior intelligence is resisted. It threatens the narrative of progress. Modern civilization rests on a powerful assumption that we are moving forward, that technology accumulates, that knowledge grows, that collapse is temporary and recovery inevitable. If intelligent species existed before us and vanished, that assumption collapses. It would mean that intelligence does not guarantee survival, that technology can be lost permanently, that progress is not a straight line but a cycle. This idea destabilizes more than history. It destabilizes confidence in the future. It also challenges human exceptionalism. We like to believe we are unique, chosen by evolution, the first to think, the first to understand, the first to matter. If others came before us, we are no longer the beginning. We are a repetition. That realization carries moral weight. It suggests that our choices matter more than we think, that our mistakes may not be new, that the warnings we ignore may have been ignored before. This is where myth returns, not as fantasy, but as memory. Across cultures, the same stories appear again and again. A golden age, a great catastrophe, fire or water from the sky, knowledge bearers who survive and warn future generations, gods who are not gods but teachers. These stories are often dismissed as imagination, but myths endure because they carry meaning when facts are lost. They compress history into symbols that can survive collapse. If earlier intelligences existed, myth may be all that remains of their warning. The final question then becomes unavoidable. If evidence was hidden, was it hidden deliberately? Or was it hidden because we were not ready to see it? Sometimes knowledge is not suppressed by force. It is suppressed by disbelief, by the refusal to integrate information that disrupts identity. A civilization that believes it is the first will not look for predecessors. A civilization that believes progress is inevitable will not study collapse. A civilization confident in its permanence will ignore its own fragility. Perhaps nothing was hidden by a single hand. Perhaps it was hidden by a story that says intelligence begins with us, that says the past is simple, that says the future belongs only to those who keep moving forward. If that story is wrong, then the most important evidence may not be artifacts or ruins or chemical signatures. It may be the pattern itself. Civilizations rise. They transform the planet. They believe they are unique. They fail. And time erases almost everything they leave behind, except the question, are we the first or are we the next? And if this question stayed with you, even for a moment, feel free to support the channel by liking the video, sharing it with someone who enjoys these kinds of ideas, and subscribing if you want to continue exploring them together. It helps this work reach others who are asking the same questions. If we are not the first intelligent species on Earth, then the evidence was not only hidden in stone and sediment, it was hidden in plain sight, scattered across anomalies, dismissed as coincidence, and buried beneath certainty. The past may not be empty, it may be warning us, and whether we listen may determine whether our own traces become just another faint chemical layer in the rock, studied by someone else, asking the same forbidden question we almost never allowed ourselves to ask.